Today we are going to look into JSON API download from the web page. The data source for this lab is the Waka Kotahi Open Data Portal. This provides different sorts of traffic data in a variety of formats. In this lab, we will download JSON data file. We will explore the graphical interface on the website and discover URLs that we can use to write code to download files. The TMS Daily Traffic Counts API page has data on the daily traffic counts at each monitoring site. On the left of the table of data is a little information icon. If you click that, the left-hand side bar shows information about the data set, and there is a I want to use this at the bottom. If you click on I want to use this, you get a new left-hand side panel, and within that panel, there is a View API Resources. Click on that and you will see a GeoService URL. If you copy that GeoService URL and navigate the browser to that URL, you get a page with a form at the top and tables of traffic count data below. If you modify the format in the form at the top of the web task and click Query Get, you get a page of the traffic count data in JSON format. Copy the URL for that page, write Python code to download that page directly as a JSON file. Save the file as traffic daily underscore traffic underscore counts.json. So first we will import the libraries. We import request and import JSON. Replace with the target URL. So the URL is this one. Fetch the HTML content. Response equal request dot get URL. Response, when we print that, we get 200 in bracket. Check if the content type indicates JSON. So response dot headers square bracket content dash type, and we can see that text application JSON. Check the JSON content. So response.json gives us all these tables over here, and you can see that each the table is in curly braces. So we have the title, and then we have so we have region name, we have site reference, we have class weight, site description, line number, flow direction, traffic count, and we have the features. So these are the values. So object ID is 1, start date is, so this is where the table starts that we are interested in, the table of values. So we have many tables over here. So let's look at this further. With the open bracket, we'll put a name of the file. What we are doing over here is writing this JSON file, JSON data in a file, and the file name is daily underscore traffic dot underscore counts dot JSON, comma, and then we will have W for writing, and then we close the bracket, has F and the colon. JSON dot dump open bracket response dot JSON open and close bracket comma F. So here what we are doing is parse and save the JSON data. Then we load the JSON data again with open bracket daily underscore traffic underscore counts dot JSON comma R for reading has F colon JSON underscore data equal json dot load bracket f, and when we print the data, so we can see that we have the JSON file which we have read again. So we have all the attributes over here. So we have a start date, site ID, and description of class weight, description of site description, description of lane number, flow direction, traffic count, and then here we have the attribute values. So object ID is 1, start date is this, the site ID is 39, region name is Gisborne, site reference is 002, 00444, class weight is light, site description is 200 meters north of Bell Road, lane number 2, flow direction 2, traffic count 12468. So, and the rest of the tables over here and the values. Let's look at this further. Convert JSON data to data frame using JSON underscore normalize. So df equal, so that's the name of the data frame, df pandas pd dot JSON underscore normalize, and open bracket JSON underscore data, comma, record underscore path equal features. Now we have features over here because when we look at the printed JSON file here, so we will see that unique field, so object ID. So why do we have features? So when we these are the fields. What we have over here is record path equal features. So here, so this is where the table starts, and that is named as features. So that's why we will have features. And when we print that, we will see that the column names are starting with attributes dot object ID, attributes dot start date, attributes dot site ID, attributes dot region name, attributes dot site ref, attributes dot class weight, attributes dot site description, attributes dot lane number, attributes dot flow direction, attributes dot traffic count. Now we have attributes and then dot and then the name, because if you look at these features, square bracket, curly braces, and starts with attributes. So the names of this is given as attributes. So that's why we say the column names are reading automatically as attributes dot object ID, attributes dot start date, attributes dot site ID, attributes dot region name, and so on. And there are how many tables? So we look at the index and we see 2000, about 2000. Yeah, 2000 tables, 2000 data. Okay, so in this one, in this code over here, we will replace only the first occurrence. So what we want to do is get rid of attributes dot. So this is how we do that. So the name of the data frame dot rename, and open bracket, columns equal lambda space col colon space col dot replace, open bracket, attributes dot, in this apostrophe, comma, and then we will have apostrophe, comma, 1, and then we close bracket, comma, in place equal true. So when we print the data frame, we get all the attributes are removed, attributes and dot. So we have the names of the column has object ID, start date, site ID, region name, site reference, class weight, site description, lane number, flow direction, traffic count. And we have 2000 data